Welcome to part 3 of 5 of Competency 17 practice test questions. Number 9, for a standard normal curve, what is the area to the right of z equals 1.3? Okay, part of your clue is talking about the standard normal curve. That means we need second, vars. Now we are talking about the CDF, not the PDF. Okay, to the right, this means to the right, that means this is our lower bound. So we have 1.3 inner, and our upper bound in this case is going to be our given 1E99 inner. If you don't know about that, I recommend that you go look at prior videos or go to all those vast resources on the internet. They've got some great explanations out there. Okay, you leave this because it says standard normal. We leave mu at 0, standard deviation at 0. That's just the one they teach you the basics of in college. Okay, now we need to do a little bit of rounding, and C is our option. Number 10. The amount of soda dispensed in a paper cup of an automatic machine has a mean of 6.2 ounces and a standard deviation. Okay, let me go ahead and circle this. Standard deviation of 0.4 ounces. What percent of paper cups will have between 5.7 and 6.0? Okay, this is our lower, this is our upper. Okay, and how do I know what to do? This is just talking about the normal curve, what we did above. You'd have to think about what options are given to you on the TI-84 that would match with these items given and the particular way the question is asked. You can go back and watch our videos. Anyway, let's do this. Second, vars 2. Okay, lower bound, 5.7. Enter, upper bound, just plain old 6. And our mean, they gave us 6.2. Standard deviation, 0.4. Okay, inner, inner, inner. Okay, we had some rounding again. And they tell us to round, but we can see that from all of our options here. Number 11, in thousands of dollars, the mean salary of all high school teachers in Texas is 52, with a standard deviation of 3. What percent of these teachers can earn more than 49,000? Okay, this is important. In thousands of dollars. This means our mean is actually 52,000 and our standard deviation is actually 3,000. So we will make the choice to take off these zeros when we calculate. And the way this problem is, this is going to be, and it says earn more. This will be our lower bound under our normal curve. Okay. So second vars, I'm going to go with 2. Okay. That's our lower bound. And actually, I'm saying that it says more than. We need to use 49.5 and not include the 49 as is because it says more than. Very clearly says more than. So 49.5, enter. Our upper bound is the 1 second E99, enter. Our mean was 52. Standard deviation is 3. Okay, notice we are going to assume it's thousands, but we didn't mix the changes, okay? That makes a difference. Don't be sucked in. Okay, and we're looking at option B, and that's correct. Great. Okay, option, number 12. Okay, we aren't going to use an operation on the calculator, is what I want to say. We are going to have to use formula, but you should know these formulas, and I've posted them and used them during calculations in prior videos. You may want to go back and look for those when it has things about standard deviations, variance, all those things. In a normal distribution population, the mean is 24. Standard deviation is 4.8. Which one of the following is completely correct with reference to the distribution of sample means of all sample size of 64? Okay. When this was the central limit theory, when you have samples and all of the sample sizes will be the same, that's one of the requirements. Guess what? There it is. There's our requirement. It states that as you take more and more of these samples, all the same size, their mean is going to be distributed close to what your population is. And notice they discuss population right there. So that means 24 will not change. The more we take, it's just a fact. It's going to come closer and closer and closer. Okay. All right. So you can go back and read about that or listen to the videos. I didn't explain it as well as a book would or other videos that focus on this topic. Okay. So get rid of B and D. Okay. Now we have two things right here. The thing is that those theories and properties, they do not say the standard deviation would be the same. Logic tells you that a sample is not going to be precisely exactly like the population. The odds are against you. The mean will be. And that's the theorem, and that theorem holds. But this right here, 4.8, I doubt that. So logic tells me that's not going to be. Okay, so I'm going to pick C, but I just want to show you something. When we go to calculate these things, do you remember that I said, hey, that's a sample. So we need a sample deviation. And when you plug it into the TI-84, that's what they're asking for when you do these things. So that standard deviation of X bar actually equaled, you may not remember, go back, write this down somewhere. You are going to take that population deviation and take the sample size of 64, put that in your calculator and see if we don't come out with a 0.6. Okay, 4.8 divided by second square, put your 64 under there. Yes, it does. So C's our option. Okay, that's the last question in this video. It'll be a couple hours and we'll have the next 4 questions, which will be part 4 of 5. Thank you so much for watching. If you like our videos, would you please like us with a thumbs up and consider subscribing? Thank you.